Uh,
So let me confirm. So Nakai-san will present 5 10 minutes, 5 minutes or something, and we will discuss.
Yeah, I think like 15 minutes, Nakai-san can present,
sure.
and 15 minutes are something question and answer, Q&A and discussion.
Okay. First of all, thank you, Watanabe-san, for a nice introduction. Could you see the slide, everyone?
Yeah.
Okay. So I'll start. I'm not sure I completely understood well how to the way of presenting this in Project Club, but well, I will present this paper that was suggested by Tsuchiya-san. It's a bit long. I did not know this paper before, so it's very interesting. Interesting that there's the previous study using kind of measures and similarities among different numbers and 50 years ago. But it's the paper itself is very long. It's about 50 pages. So I will just present very main findings of the first half of this paper. So I'll start, and I would first talk about background. The one previous study by the same author, and they propose a principle of second order isomorphism. Isomorphism. So what is it? So this is a relation among internal representations are similar to relations among external objects, but not kind of similar to ideal as a Korea structure. But basically, it's saying that you can say that Korea structure correspond to the internal, what they are saying internal relations among internal representations. We can interpret it as a Korea structure, but they say that the relations that structure correspond to the external relations among external objects. And in the previous study, they found that on using they asked participants to judge similarity among different states, 15 states in the United States, and basically the two conditions in the first condition they saw actually the boundaries of the cartography of each state physically visually presented, and in the second condition they just presented the names of that state. Of course, some Americans don't know exactly, or even Japanese people cannot imagine exactly the shape of the boundary. So it really depends on the subject knowledge or education levels. But they found the similarity structures among the first condition and among the states in the first condition and second condition are well corresponded. However, in this previous study, as I said, that they heavily depend on the education level of the participant, and also they tested only two conditions. So in the current study, they expanded this idea to include more variety of conditions, not only two, but more different formats. And so and also they wanted to use something that does not heavily depend on the subject education level. That's why they chose number forms in this study, and they performed a similar experiment analysis. And so they use 9 different forms and spoken word, printed word, Arabic numerals, Roman numerals, finger counts, tally marks, rows of dots, regular polygons, and patterns of dots. Probably you may know most of them, except for tally marks. I don't think that we use often. now currently, but other forms are basically we are all familiar with these kind of forms or shapes, and but only for and they use numbers from 0 to 9 except for Roman numerals which don't have 0. So there were 4 participants and they performed 4-hour experiment because there were 24 conditions. Well, I will explain later why there are 24 conditions, because even if there are only 9 different formats. So they compared similarity, they performed similarity judgment all for all pairs of numbers as shown in the right side of this slide. They presented two numbers and they judged from whether the most similar is 10 and least similar is 0. So then they just the participants slided a marker between 0 and 10. And there are also interesting part in this experiment is that the distinction between presented forms and judged form, that the form numbers can be presented as Arabic numerals, like on the upper right side, but participant can ask to basically judge not by the presented form, similarity of the physical presented form, but in their asked to judge based on the dot patterns corresponding to that Arabic digit. So basically, based on distinction between these two forms, there are ideally there are 9 to sorry, I also have to add the abstract concept idea. In addition to the 9 number format, there also one judged form of abstract concept. Because abstract concept means that the magnitude are 1, 2, 3, 4, 5, and 9. This was not presented physically. This cannot be presented physically, but the participants were asked in this condition to judge based on the magnitude. So ideally there are 9 to 10, 90 possibilities of combination, but they selected only a part of this condition because they don't have much time to ask participants for. So they only have 24 conditions, but still it took 4 hours for each participant. The first analysis, they focus on this 3 to 4 combinations of presented and judged forms, and they compared similarity structure. Well, they first calculated similarity matrices among numbers, and then compare similarity of similarity correlation between similarity matrices for all combination of these conditions, and they found that the correlation are always higher for the judged forms compared to the present form. Present forms are 0.093, but judged form, the average correlation is 0.867, so it's a bit always high, better correlated among different conditions. And when they use all of the 24 combinations, they again find that that can be explained only by the effect of judged form, because there are highly correlated. The high correlation between original or set of the correlation the values and mean when those are the mean across presented forms, so that even by averaging all the correlation but ignoring or possible presented forms. but this calculation did not affect that correlation value. So they concluded that the present form did not have any influence on the correlation similarity judgment. And based on their assumption that the principle of second order is more forms, they assume that the internal structure of relations are among the different numbers are similar to the external relations among objects, but it's this assumption stands only for this small part of the result. So only part of the result, its hypothesis is true. So they checked how those different presented forms have influence on the representations on how they are differed across the relationship between the presented and judged form. And so they perform multidimensional scaling using the similarity measure, correlation measured across 24 conditions. And they found the conditions are basically clusters based on the judged form. So the letters correspond to the presented form. So even with the the conditions with the same presented form can be clustered together, but a bit made a different cluster based on the judged form, which described as a surrounding curves. So this visualization also shows that those number forms are basically judged based on the judged form and internal representation of numbers rather than the diverse presented forms of number symbols. So, and this is the last slide of my presentation. Okay. Thank you for your attention.
Okay, thank you for Nakai-san. This paper is very voluminous, but yeah, you explained very briefly. And so, do you have any question or comment?
Hi, thanks for presentation. Can you hear me?
Yes.
Yeah, I'm very interested in this current figure. So let me confirm. Does this diagram show that whether or not something is judged by numbers or other forms, kind of counting or dot or something like that?
Well, it's for some conditions they discuss. They also discuss add some interpretation. For example, if we see the spoken word and printed words, then on the bottom side of the whiteboard, and they are close to each other when compared to Arabic numerals on the left side. So both spoken word and printed words, they interpreted that it's basically presented as, well, the linguistic information rather than like dot pattern or magnitude information or counting information. So that I think even this visual representation somewhat represent how or correspond to how the participant process these numbers in a different way. But this is if this is just an interpretation, I mean, we cannot know exactly whether the participant actually use counting strategy or something.
Thanks. Yeah.
Yeah, actually, they present like concrete counting representation. Well, this is interpretation.
Another question?
Okay. Morgan-san.
Or Asai-san, if you have say something, please.
Sorry,
Asai-san.
it's not, okay, go ahead.
Please.
Please go ahead, yeah.
Perhaps this is Nakai-san's expertise, but when children can understand the correspondence between these kind of different form of numbers, so yeah, like Arabic number and you know, yes, do you have evidence?
Well, I think most of previous study is basically dot pattern. I mean, the children start to learn the correspondence between dot patterns, Arabic numerals, and it depends on the country. Basically, for 5 to 6 years old, the first year of the formal education. But I'm not sure it's how they learn the correspondence between like Roman numerals. Other like 30 or polygons.
But they can easily understand the correspondence between like, finger number and between finger and the dot or Arabic number, which is kind of easy, right? Perhaps.
Basically, so finger counting is much easier than the Arabic numeral. But for that, the problem for children is that even if they are successful in the finger counting, they does not, and even if they can understand order of like 1, 2, 3, 4, 5 order, but even if they can memorize order of number words, that does not mean that exactly correspond to the number of fingers. So it's gradually developed from the
Interesting. Oh, I see. So perhaps this kind of experiment is maybe not easily conducted in young children, right? So maybe school age.
Yes, part of them can be performed for the children. Yeah, already the 5 and 6-year-old children can be tested using a part like spoken word, Arabic numerals. Not in all schools, but at least in France, say 5-year-old children already learn Arabic numerals. So some of them can be tested, and yeah.
Thank you.
So can I ask a question?
Sure.
Yeah. So in this slide, the author shows like the cluster between judgment forms, right? So how about between numbers, right? 1 and 2 or 1 and 5 or something. So how the authors also showed the result?
Yes, in the later part, they show some result. Can I just finish this slide? And I did not prepare this on this slide, but I can.
So I read the result briefly. So like 1, 3, 5, 7, or 2, 4, 6, 8 or something. Odd number and like not.
Yeah.
Sorry, I don't understand. I don't explain it. That's right. Or these. So number categories are there, right?
Yes, partly there. This is again this other slide. So for some, this is not super clear.
Mm.
For example, on this, you see this slide of this tallies,
Mm.
marks. So the smaller numbers organized together in this the two-dimensional space, and larger numbers are more on the top part. And this is Roman numerals, and also it's saying that 1 to 3 a bit made a different cluster compared to the other numbers. So it's interesting that it's especially in the 1 to 3 is kind of special numbers, because it's the number of lines is exactly corresponds to the number of the quantity, especially in the numbers info from 1 to 3, and distinct from other more abstract format.
Yeah, I see. So for thinking about the children, yeah, I think there's a relationship between understanding order of numbers and these similarity between numbers according to previous discussion of you, right, like Moriguchi-san and something. Thank you. So there's a time. So do you have any question, comments? More we can.
My very naive question or it is maybe comment. If these authors' principal second order hypothesis is true, so functional similarities among internal representations parallel structural similarity among outside the world, right? If it is true, so there is a possibility that people who are blind or have hard of hearing have different internal representations of numbers. Yeah, this is also applied to children's case. So is it possible? My understanding is correct, yeah.
That's very interesting topic, and I remember there's a braille reading experiment with participant, blind participant, and they found. I remember they found the activation. This is a neuroimaging study. They found activation in the auditory cortex. I think. Sorry. I think the visual cortex for the performing the number calculation tasks, if I remember correctly. They discussed kind of rewiring the brain activity patterns for the blind participant. So I think that it's kind of processing mechanism can be different between normal participant and blind participant.
Yeah. I think it is very important theme for our Korea structure project. Yeah.
This is not the question for Nakai-san, but perhaps we all have to think about that. The internal representation in this paper is different from Korea structure we call. Paradigm is very similar, right? So how can we differentiate between this internal representation from the, Korea structure? What do you think about it?
I'm not sure that it's their definition of internal. I mean, internal is very vague, but at least for the isomorphism principle, isomorphism does not stand in the Korea structure. Basically, if I understand correctly, they basically focus on the internal structure, and that does not necessarily depend on the outer external of relations between objects. But for I didn't find in the personal, I didn't find so much difference join what they call internal relation and qualia structure.
Yeah. Okay. Taji-san, what do you think?
Yeah. I think very similar or yeah, more to say I think it's their same at least in the sense of information structure between the similarity matrix. They compare similarity matrices and outside world and internal structure, and this is the way we are doing in the Korea structure program project. It is, I think it is same. Yeah.
Yeah. Yeah, thanks. So, yeah, opinion. Yeah, because task is paradigm is very, very similar to the color similarity judgment in this. So, and when I talk about my study about color similarity task, people say, yeah, what is different from other similarity research or so yeah, so maybe yeah, there are several something like stimulus is very briefly presented or several aspects to the differentiate between Korea structure and other similarity paradigm, but we
Yeah.
need to
I think one different thing is in our experiment of colors or something like that. The list the color stimuli was presented, and our participants as participants were asked to judge as soon as possible, right? Yeah, but other similarity judgment tasks in the other experiment, they judged, they consider and judged, so very cognitive. They're cognitive. So in Tsuchiya-san, Kawakita-san's experiment, the participants did not have the time to judge the similarity, but respond as soon as possible. I think this is a different point. Project from other.
That is true. That in this paper they judge using self space so that they can use 1 minute or 2 minutes for any stimulus. So if we have time limit, maybe the result will be different. We can refine the paradigm based on this study and use make some new paradigm for the compare similarity using similarity judging of numbers.
All right. Yeah. Thanks so much. Yeah, that's good.
Thank you.
Okay, so yeah, thank you very much. Do you have any comment? So I think the time is about to finish. Okay. So thank you for Nakai-san.
Thank you.
Okay.